So I wanted to start making a series of videos talking about the development of the game, how the game was built, and some of the little tricks that I did to get everything working. And this video, I want to start with this under the hood video where I talk about how we did the galaxy, or how I did the galaxy, how I did the nebulas, and how we go from one galaxy to the next, and how the rendering works, and the ordering, and all that stuff. So let's just go ahead and I'll unpause this and we'll fly through space for a moment, and then we are in the Unity editor right now, so this is what I see when I'm developing it. And the frame rate may be a little bit lower because the Unity editor is typically pretty slow. So let me go ahead and pause this, and we're going to switch over to scene view so we can actually see what's happening. And this is where it gets weird. So here's the player, and this is the ship. And these green wireframes, these are colliders, and they do a lot of different things. So, for example, this big, and oh, my cursor's actually hidden, but that's okay. You see this one, this big capsule collider is actually used for detecting when you're aimed at a planet. We could have used a raycast, which would basically just shoot out an invisible beam and check it. But the reason why we wanted to use something that had a little bit more mass to it was so that if you were just on the edge of it, it could get the planet as well. And then if we were to unpause this, you will see, oh, hang on, I switch back. You can see us flying through space. So one of the things I want to do is I want to talk about how we handle the nebulas. So what you'll see as we zoom out, you'll see this big dome, and these are all of the nebulas that are in our current galaxy. And these aren't actually 3D objects. These are actually sprites. And if we click on, well, we'll try to click on one. You see all the nebulas. It's going to be hard. Well, I can kind of, you see I can pull one out. Whoops, hang on. Let's go back. Let's undo that. You see I could pull one out. And that's exactly what it is. And what we do is we populate this dome. We basically have two layers to this. Well, several layers, because the dome is multiple layers as well. And then we have this cube that goes all the way around. And essentially what we're trying to do is we're trying to cover up the emptiness of space. So as you fly through space, and let's unpause this. We'll have to go back. But as you look at it, you'll see there's a lot going on right here. So the reason why you're seeing objects disappear is we're flying farther and farther away from them. You're also going to start to see, because we're starting to cross over into a new galaxy, you're going to start to see the nebulas change to these orangish red, yellow orangish red nebulas. So it's all going to eventually, as we cross over, because we're flying up north, they're all eventually going to start to change slowly but surely. And this entire dome, all of this is going to sit still, but the cube. Oh, see, okay. So here we go. To interrupt myself very quickly, you see they're starting, and they fade in. The ones behind us, the reason why you're seeing them pop out is because they're behind us, so we can just turn those off. You're not going to see them. And what happens is every time we turn one off, we spawn a new one in front. Now the visual effect looks very smooth when you see it in the editor, and if you turn around, you can still see all the nebulas behind us. But the ones behind us, you will start to see it gets a little bit thinner as we're going behind, but not completely thin. And then if we switch back, you're going to start to see, you'll start to see these begin to disappear. You can see they're starting to move out as we're getting farther away, and then it's going to start spawning them on this side. And your graphics performance will determine how many there are. For example, on the Switch, like if you look over here on this column, we have hundreds of these. But on the Switch, it would have a lot less, because obviously it can't handle like 500 nebulas. And the reason why we're using sprites instead of 3D objects, which Unity's interesting in that 3D is actually much faster than 2D. But the reason why I wanted to use sprites is for, and if you're a developer, you know about Z alpha fighting. And what that means is anytime you have a texture that has an alpha transparency, something that's not just completely cut out, but it has a fade to it, 3D programs have a difficult time drawing them in the correct order. And you will see it in this. Every once in a while, you will see something pop in front of each other. It doesn't happen that often. And because we use sprites, we're able to much better control that. We can say, if we go back and we look at the our sphere, and again, the sphere is layered, but we can sit there and we can determine. You see, if you look over on the right side, where I'm clicking, if you look at, like, for example, here, I'm moving this up and down. This is farther back than the ones over here. So we're able to set its sorting order to be underneath. The problem that happens with 3D objects, 3D materials, and this happens with sprites as well, but with sprites we can specifically set the order. Doing that with 3D is a little bit tricky in Unity. You can do your render cube, but it's kind of weird the way it works. But what happens with these objects, and again, this has been a problem in 3D development forever. Let me, I need to fly towards a planet, so let me try to find some planets over here. But what happens is that the idea is that it should render in the order of what's closest to the camera, whatever's closest to the camera. I really like how this looks. We've got actually a couple different visuals here. But what happens with, or a couple of different sprites. But what happens is that it's measuring the distance, but if you have an object that's turned sideways, it could actually have a farther distance, but it should be drawn in front. And back in the day when I was working in Adobe Director, we had this really weird trick where we could create one triangle and move it to the edge of an object to force it to render in front. It was the worst thing ever. But this is much better. We didn't have those sort of features back then. So the other thing I want to show, it's kind of hard to tell because the resolution, we're kind of in a smaller screen right here. But you can see these are these asteroids trying to fly through. But what you'll notice is we never actually fly into the nebulas. So the question is, how do we do that? How is it that it always seems to go around us? Is that part of it? The answer is no. We are actually flying directly into these nebulas. But what happens is that as we get close to them, let me blow up this asteroid, we start to fade them out. You don't really see it, though. And the reason why you don't see it is because there's always one underneath it. So what actually looks like is happening is instead of a nebula fading out, another one is fading in. You see that right there. That one faded in. So you can actually see that. It looked like it didn't actually fade in. It was already there. But there was a darker one on top that faded out. So it just looks like more and more are starting to come towards you. So it's just a little bit of an optical illusion. Now, another thing we're doing here is we're actually rendering at, there's a little bit of pop-in. If you look at the bottom, that's an instance where we didn't have the perfect ordering. There may have been two sprites that were just so close to one another. I probably should have just shot that. That it was having a hard time knowing which one should be on top and which one was on bottom. Again, I'm trying to find... Oh, we are so far away from planets. I want to show... Okay, here's a planet we'll fly to. But I want to talk about the way we're rendering the scene, because we're actually rendering multiple resolutions at the same time. Now, because we are pixel art, or I wouldn't say pixel art, this isn't pixel art, but it's rendered at a lower resolution to look like it's retro gaming. And I'm going to pause this for a moment because I don't want to get here yet. Well, we got a long ways to go. But... And you'll see the planet starts to show up because the nebulas in front of it are they're starting to fade out. But now we're getting really close, so let's go ahead and pause this. So what we're doing is we're actually rendering multiple resolutions at the same time. So the top layer is the ship, the cursor, and that's just about it. The UI stuff is kind of independent. It's not what we call a render texture. But underneath that, we have our star field. Well, the top layer, I should say, it's 640 by 360, so that's a widescreen format. Now, your actual output is 1080p, but what we do is we take a camera, we project it onto an image. The image is 640 by 360, and then we stretch it back out to 1920 by 1080. The star field underneath is rendering at 1920 by 1080, and the reason why we do that is so that it's smooth. Or, excuse me, not smooth, but we have smaller pixels. If we render it at a lower resolution, then it's going to be harder for those to be seen. Well, not harder to be seen, but what will happen is that they'll go from being very large pixels to even larger pixels because we have to fit a single pixel into a 640 by 360 grid, so that becomes much more difficult. So if we render it at 1920 by 1080, we can have much smaller stars, and as they get closer, they can actually scale in. If you don't do it that way, they're just going to go from big to even bigger as they fly by you. And then underneath that, we have what you're going to see here in a moment, and that is the layer. That is the planet information. You'll see the ship is on top. Actually, it looks like the cursor. I was wrong. The cursor is underneath that layer. So the ship is on a layer. The stars are on a layer. Actually, no. I'm wrong, because the stars are actually underneath it. So the second layer, it's been a while. The second layer is the UI for the ship, the planet information. And then underneath that, we have the stars. Underneath that, we have the cursor. And then we have the planet and all the nebulas. All of those are rendered at 360p. So, and I do want to show, let's try to go back, and I want to show, we're not going to land on the planet. See you later. But I do want to show how the stars work, because it always looks like you're flying into space and there's stars all around you. And this is a real killer, but this is how every game does it. I'm pretty sure this is how every game does it. I would hope this is how every game does it, because this is probably the most straightforward way to do it. But the stars, how do you think the stars are working? There's the question. How do you think we're doing the stars? Because it's not nearly as complicated as it looks. And the answer is, it's basically just a window that stays in front of the ship that spawns star particles, and then as they fly by, we get rid of them. So let me see if I can show this. So here's the stars particle. This may be very difficult to show, but here it is. Here's our window of stars. You could kind of see, if you look really close, you can see the stars. And really, I'll fly through with this select, and we have to go back. You can see what's happening. It's the problem is we can't really control the ship when we're in this mode, unfortunately. But it's there. Let me pause one more time and just select it. And you might be able to see it emitting. Yeah, you can't really tell, but that stays in front of the ship no matter what. And then it looks like, as you fly up and you fly down, it looks like they're going around your ship, which they kind of are, because when it spawns them, what it does is it moves them forward, but it does it in a world space. It doesn't do it in, you've basically got two spaces you can do in Unity. One where the stars will follow the particle, which is this big window in front of us. Then you've got one where as they spawn out, they'll stay relative to space, so they won't follow it. So as they're spawning around the ship, if I turn left, for example, I'll kind of cut through the ones that are coming from my left, and it'll move across. We also have a sun way out there, and the sun, what it does is it basically just rotates around this cube that follows the player, and the cube is essentially the edges of space. It's just blackness that hides the background, and the sun stays just slightly inside of that and just rotates around the entire time. So you can't actually fly to the sun. It's always the exact same distance from the player, and that sun is nothing but a sprite. That's all it is. And we have a shooting star out here, and maybe we can take a look at what the shooting star is. So I'd have to find it. So it would be under, it's been so long since I've been in here. I've mainly been in the 2D elements and on a planet. Space objects, it's going to be, here's a shooting star. So here is a shooting star. And it's really just a simple particle system, and literally it's these pluses. And you're probably saying, why is it pluses? Why would it look like that? And why does it look so much different when you're far away? And again, it's really just sort of an optical illusion. The way that we take these plus objects and then draw it into that 640 by 360 grid, it kind of chops it up a little bit. And because they're stacked on top of each other, it just creates this kind of trailing effect, which strangely just looks really interesting, and it looks very organic. It doesn't look like a particle system. It looks like it's a lot more complicated than it really is. So let's actually, if we could, are we close to any planets? We're kind of out in the middle of nowhere. Well, we got one in front of us. We got a little bit of thruster here. There is one problem, and if you've ever been thrusting when you cross, actually, I can show you this here in a second. So the thrusters are in Unity. Those are trail renderers. They're pretty cool because they can kind of bend, which they really don't. They're just sort of following. They look like they're bending, which I guess technically they are. And I screwed it up. Hang on, we have to go back. Well, actually, it may not have happened right there, but the entire solar system is on a treadmill. And the reason why we have to do that is because in 3D software, you have your position, your X, Y, and your Z. We're moving along the Z axis. And if that number gets too big, it becomes very inaccurate, and we have to be very accurate. And I didn't realize this until I had flown about 60,000 Z units north. And then when I was landing on planets and I was leaving the planet, I started to realize that when I was leaving the planet, I wasn't starting right in front of the planet. I was a little bit to the left. I was a little bit back. And that's when I realized, oh no, something I completely forgot about was that the bigger the number, the less accurate it gets. So what we had to do is we had to put the entire system on a treadmill. So the idea is when you go 6,000 units forward, it moves everything back. And the trail renderer, if you ever fly sometimes through one galaxy to the next, you'll notice that the trail of your ship's trail will get a little bit janky and then fix itself. That's because the trail renderer doesn't do a good job of moving with the galaxy. So that's kind of a bug that it's not a big deal. It doesn't happen that often, but it drives me crazy because I know someone's seen it. So let's go ahead and land, and we're going to show, let me see if I can find the objects, how best to show this, because I want to show how we're actually landing on a planet and what happens when we go to a planet. So we have that's the in-world anchor. I could type it, but my keyboard's on the other side of my microphone right now. So, well, let's just do this. We're going to start to land. We're going to pause. And you're seeing a lot of crazy stuff right here. These are planets. Oh, actually, hang on. No. Wait. Okay, so the in-world anchor was that. That's what I thought. I thought that's where we're at. So, what we're looking at. So what happens in order to go from 3D to 2D? 2D, when you're landing on a planet and you're moving throughout the world, X has to be left and right. Y has to be up and down. But based on where you land on a planet, it could be any direction. So what we actually have to do, when you start to land on a planet, when the camera swings around to the front of your ship, what we're actually doing is we're taking the entire solar system and we're putting it into this in-world anchor. It all goes into this. We rotate it to make it flat to where X is left and right, Y is up and down. Now, because we take every single object and put it into this anchor and rotate it, you don't notice anything because everything's rotating together. We don't rotate some of it. So you can't tell that it's actually happening, but we're flattening everything out. Then we move the entire solar system into position from where the starting landing zone is, wherever that may be, our tile grid, our massive tile grid, which holds all the world. So we rotate it and we move it into position. When you take off and the camera spins back around, we do the same thing. A lot of people think that we're doing some sort of loading trickery when that's happening. We're not actually doing that. We're doing something even stranger where we're just rotating and moving the entire solar system to get it into position to where we can actually, every time we go into the 2D elements, we're always in the exact same position. When your character jumps out of the ship and lands, they're always going to be in the exact same spot. And you can see a lot of crazy stuff happening right here. One of the things that happens is we turn off. Let me see if I can find. Okay, well, here's the ship. So this is what you see when you've landed. And you'll see these are the X's for the edge of the world. The reason why you're seeing these is because we moved everything, and those edges don't move. But you can't see them because they're flattened out. There's our post. If you see that little spirally thing, that's our post-processing, which gives us a little bit more. Mainly what we're doing for post-processing is we're doing more contrast to get a little bit more color. And so we can't see. Let me try to go into a room, and then we'll go back. We really okay. So here we go. And here's what it looks like. As you can see, now you will notice that you're just seeing some stars. That's because here's the background that the creator has selected. And so if they had, so if we go, let's go back real quick. We go back. You still can't see. I'm not exactly sure why. Well, you could see it. This is render texture stuff. We're rendering stuff out of order, but you can see now and by the way, the reason why this box is wobbling is that's our ship, and that's connected. That box actually tells us what we should show and not show. So any planets on the other side of the screen that we couldn't see, we turn those off. We turn all those nebulas off. That's why you only see nebulas on this side. We turn off all the nebulas on this other side because you wouldn't be able to see them. So it helps with performance. So we only have these nebulas, all these planets, these asteroid fields, all this stuff. Some of it's a little bit too high and low, but because a creator could make their world any size they want, you can end up way down there. But that box, the way it works is each of these objects has, I can't see the, let me see if I can, you see the circle, the sphere, excuse me. That sphere determines the box is touching it, then that sphere will say, okay, we can see this when we're still here. So let's go back, have another look at this. Let's see if I can click on this because we're very far away. Oh, that made it much worse. So we'll click again. And there's the actual game. Nice item over there we could get. And that's what it looks like in the editor. So let's play this for a second. We have the way we do the parallax scrolling is oh no. Uh-oh. Oh. That's embarrassing. Now let's fly back into space. Let's get out of here. So let's go back and have a look. Let's find the ship again. I keep losing everything. Oh, actually, you're about to see. Here's the ship. So you're about to see. Let's see what it looks like when this happens. I'm always in game when I test this. So let's see what we can see. What you're probably going to see is the ship completely disappear because it's going to go somewhere very far away. And it did. So that's the entire solar system moving. And here's basically the entire game. It all exists, and here's that cube I was telling you about. That's the cube that follows you. And there's our solar system inside of there. And let's see, is there anything else cool that I could show? It really kind of ruins the illusion of everything. Oh, and there's our ship outside the planet you could see. And how are we? Yeah, we're facing down. We're facing way down. And there's that collider that hits it. The first thing that it checks everything it hits. One more thing. This is Unity 6000, which is the newest version of Unity. I went to this version. I usually use an earlier version, but I upgraded to this version because it was required. Well, it wasn't required, but my SDK, my Nintendo SDK was out of date. So I had to get a new version. So I said I may as well get the newest version so it'll last the longest. And I like to use raycasts. Raycasts are great because you don't have to have an object for them. And a raycast just shoots out an invisible beam. First thing it hits, it checks. And that's how I do the shooting. So let's go look at that for a second. So when you shoot, and every game does this, every space game does this, Star Fox does it, everything does it. It's actually completely ridiculous the way the physics work, because you think about it, you're shooting towards your cursor, but when the bullets hit the cursor, they don't continue going in the same direction. They turn towards, they go straight towards where the camera is facing. So it's not, the physics of it are preposterous. But I was using raycasting. I was shooting out a ray from the center of the target, straight out in the center, the middle of the screen, the straightest direction of the screen. And it worked fine on PC, did not work on Switch. And I went on the Nintendo forums. I said, does anybody know about this? What is it with this version of Unity? Nobody was sure. One other guy said he couldn't get raycast to work on the Switch, but only on the Switch, but he just gave up on it. And it's one of these things where that was a really fast asteroid. You're spending so much time building so many features, you don't want to sit there and spend 12 hours troubleshooting something. So I spent a little bit of time on it and eventually just gave up and said, you know what, we're going to have to do this differently. And so what I ended up doing was I actually took out the raycast and put in a collider. So the cursor also has a capsule collider that goes out, stays straight within the direction you're facing, and we have to do it that way. But a raycast is certainly the preferred way to do that. Although in fairness, you get a little bit more room for error by having a capsule, because the capsule can fit the entire cursor. So if something's not right in the center, if you don't have something perfectly lined up, you could still do that. So that's my excuse for keeping it in. Let's go have one more look at our sphere. Let's find the player again. There's our player. We've got some asteroids about tonight. The way we do asteroids is similar to the Starfield. We have we just sort of do kind of kind of AI timers to determine when we should have the next asteroid spawn. And they literally spawn in front of the ship and then fly towards you. Otherwise, and you have to do it that way because you can't just have asteroids flying all throughout space. It'd be really cool if you could, but the amount of processing it would take would be absolutely ridiculous and not worth it. And that's pretty much how we handle space. The last thing I will say is that the way we spawn in the planets is whenever you cross into... Basically, we load 3 galaxies at a time. The galaxy you're on, the one in front of you, and the one behind you. When you first load in, everything's drawn, all the planets, all the nebulas close to you, nothing far away, but everything close to you is drawn. When you cross into the next galaxy, we stream in the next the galaxy that's the next one after the one you're crossing into. So those planets start to load, and then we offset those. We load one at a time, the ones that are closest first. And so that way you don't get a big performance hit, so when you cross our next galaxy, it freezes up. If you ever played Oblivion on the Xbox 360, it was open world, but you would constantly, as you move throughout the world, it would always freeze up and have a little loading at the bottom of the screen with a little CD spinning. That's because they weren't asynchronously loading everything in, or it's also possible that they were just trying to load too much in, it couldn't keep up, so they were saying, hey, let's just pause this for a second, and then once everything's loaded, we'll keep going, especially once you got up into the mountains. It was kind of strange, because it seemed to happen in areas where there was the least amount of vegetation, which you'd think the amount of vegetation would make it much worse. So, streaming in open world, that kind of stuff, I mean, that was in 2006. So we weren't even doing that good of a job with it back then. That wasn't that long ago. Something like Morrowind was such a simple game, they could stream that in pretty easily. And there's not much to this. This isn't anything near the level of Oblivion, but we are still having to... My point is that we're still not just drawing everything at the same time. One planet, then another, then another, then another. And then what we do is, so that we don't have any pop-in whatsoever, is they actually start off at scale 0, and then they scale up So you may every once in a while you might see a planet that starts off as you're flying towards anything, it always gets bigger. So we can scale something up and it looks like you're just flying towards it. But every once in a while you may see something that looks like you're flying towards it a little bit too quick, and that's because we are scaling it up in the distance.